Welcome to the MOOCs course Mechanical Unit Operations. We are discussing equipment for size reduction. In previous two lectures, we have seen different types of equipments under crushers category and grinders category. This particular lecture we will be discussing equipment for size reduction under ultrafine grinders and cutting machines category. So, let us start with for the case of ultrafine grinders. So, in general what happens, commercial powders need to have particles in the range of 1 to 20 microns on the average. Sometimes particles may have a slightly oversized compared to the 20 microns, but almost all particles should pass through 325 mesh screen having opening of 44 microns in general. So, that is the requirement in any of the commercial powder in general. So, in many of the commercial powders you need to have a finer particles of size 1 to 20 microns average size in general, whereas almost all particles passing through 325 mesh screen having opening 44 microns. So, such fine kind of particles if you wanted to have, it is better to go for kind of ultrafine grinders. Indeed, ultrafine grinders can reduce particle to such fine size. So, ultrafine grinding of dry powder can be done by two different types of mills. So, one is the high speed hammer mills with internal or external classification. So, they are more or less like a hammer mills, but speed is very high. These hammer mills, in addition to the hammer, whatever the rotor in hammer mills, the rotor consisting of several hammers, 4 to 8 hammers, swinging hammers in general. But here, in addition to these hammers, there will be some kind of a classifier also, so that to take the product away from the crushing area and then collect into the product collection vessel. So, the other type of ultrafine grinders used for dry powder is fluid energy or jet mills. Fluid energy mills where a kind of steam or dry air is in general used at high speed as a kind of medium for size reduction in these fluid energy or jet mills. Whereas ultrafine grinding of wet material is done by agitated mills. So, we will be discussing in this lecture about the hammer mills with internal classifications and then fluid energy mills, then some type of agitated mills we will be discussing. Classifying hammer mills or hammer mills with internal classifications, what we have a set of swing hammers is held between toe rotor disc as in a conventional machine, but in addition to hammers, the rotor shaft also carries two fans. Why these fans are required? These fans draw air through the mill toward the drive shaft and then discharge into ducts leading to product collectors. So, having this additional arrangement makes a kind of a classification of the material. So, that is the reason this hammer mill with these fans are known as the hammer mills with internal classification. On the rotor disc, there are short radial vanes for separating oversized particles from the required product size. So, required whatever the fine materials are there, they are carried past the radial vanes as product, whereas the particles which are too large are thrown back for further reduction in the grinding chamber. Maximum particle size of the product is in general varied by changing the rotor speed or by changing the size and number of separator vanes. The capacity of these hammer mills with internal classification is in general 1 to 2 tons per hour, producing the product of average size 1 to 20 microns in general, whereas the energy requirement is 40 kilowatt hour per ton of the product. Right, this is about the hammer mills, which is the operation is more or less same as in the case of hammer mills, but here we have a classifier, the fans and then vanes are provided, so that you can separate the product as oversized and undersized products. Undersized products can be taken as a kind of product, oversized material can be fed back to the crushing chamber for further classification. Otherwise, rest of the operation is quite similar as in the hammer mills, as that we have already discussed. The classification, the separation of the product as oversized and undersized is done by the fans and separating vanes which are mounted on the rotors. Then fluid energy mills, actually this is done by the size reduction is done by the high speed fluid medium, in general taken as a kind of fluid medium like steam or dry air is generally taken at high speed. So, this medium is passing through the particles, so then fluidizing the particles also, finer particles also. So, there will be attrition amongst the particles as well as the particles coming into contact with the walls of the container or the walls of the equipment, then also attrition takes place and then size reduction takes place. At the top of this fluid energy mills, there will be a kind of a separator where the particles are separated kind of in two different ranges. The finer particles which are taken to the cyclone separator, and from cyclone separator the fine material are collected into the back collectors, whereas the coarse or the oversized material are fed back into the fluid energy medium, fluid energy mill, which is again and again circulating under the required size reduction takes place. So, that is the basic principle in these fluid energy mills. Particles are suspended in a high velocity gas stream in these fluid energy mills, and then gas flow in a circular or elliptical path, that is depending on the design of the fluid energy mill that we have, the gas flow may be circular or in elliptical path. Gas flow may act as jets which rigorously agitate the fluidized bed. Fluidized bed is consisting of the particles which are to be size reduced, which are to be crushed, or the size of which are need to be reduced to further smaller fine sizes. Okay. So, the whatever the gas flow or the steam is there, that will be acting as a jet which will be rigorously agitating the fluidized bed of solid particles which are to be reduced. So, because of this agitation, there will be a kind of attrition amongst the particles. There will also be attrition between particles and then walls of the container. So, the further reduction of the particles takes place. Some reduction may occur when particles strike or rub against the walls of the confining chamber, but most of the reduction is caused by interparticle attrition only. Internal classification keeps the larger particles in the mill until they are reduced to desired size. Suspending gas is usually compressed air or superheated steam admitted at 7 atmosphere through energizing nozzles. So, we see now a schematic of a fluidizing energy mill. So, here we have a kind of elliptical fluidizing energy mill like kind of thing. What happens here? We have a kind of tube kind of thing. The tube is having between size 25 to 200 mm in general, right. So, whatever the feed that we have, that passes through this feed container from here, and there is a kind of a Venturi injector here, so that the feed flow rate can be controlled, that has to be passed through this fluidizing energy medium. So, air or the steam is coming from here, right. Here we can see there are a kind of nozzles. These nozzles are known as a kind of energizing nozzles which provide higher speed for this the air or the fluidizing medium that is coming in. So, moment they come with very high speed as a kind of jet. So, whatever the particle coming down from the feeder from here, so those particles will undergo some kind of reduction here. So, primarily this reduction is because of the attrition between the particles, and then that attrition is causing because of the fluidization caused by this high energy or jet gas streams coming as a kind of jets here. So, the primary reduction takes place in this area. So, that is the reason the chamber, whatever this chamber is there, that is known as the reduction chamber. Primarily the reduction takes place in this reduction chamber. Okay. So, the particles, the air stream flows like this and then comes down like this. It makes a kind of circulation within the equipment like this, but at the top we have a kind of classifier outlet as well. So, because of this one, material unspent fluid outlet is taken out from here. The classifier outlet, what it does, it separate the particles into the undersize and oversize. Undersized particles are taken to the classifier or a cyclone separator from there, and then from cyclone separator the particles are collected in a back collectors, whereas the oversized particles are coming down again here, and then they will continuously undergo kind of a size reduction until the average size of the particle becomes less than the required size. Okay. So, this is the schematic of the fluid energy mill, and then this is in general a kind of a operating procedure. So, it consists of grinding chamber, which is an oval loop of pipe 25 to 200 mm in general. This oval loop pipe is having 25 to 200 mm size. Feed enters near the bottom of the loop through a Venturi injector. Classification of ground particles takes place at the upper bend of the loop. A gas stream flows around this bend at high speed from the bottom. Coarser particles are thrown outward against the outer wall, while fines congregate at the inner walls. Okay. So, the fines are which are passing closer to the inner walls, they will be coming towards the classifier here, and then the required separation takes place, whereas the coarser particles are in general moving towards the outer wall, and then they will be coming back for a kind of a further reduction along with the fluid in a kind of oval path, because this chamber is in a kind of oval shape. Discharge opening in the inner wall at this point leads to a cyclone separator and a bag collector for product as explained. Classification is aided by complex pattern of swill generated in the gas stream at the bend in the loop of pipe. Feed particles range, it can handle as large as 12 mm particles, but it has been found that fluid energy mill works effectively. Feed particle size is smaller than 100 mesh screen. However, it can also handle the particles up to 12 mm size large as well. Fluid energy mill capacity is 1 ton per hour of non-sticky solid in general, and then product range, it can be ranging between 0.5 to 10 microns in diameter. So, we can see the degree of attrition that is causing amongst the particles because of the fluidizing medium coming as a kind of gas stream coming as a kind of jet. Okay. So, we can see that almost up to the particles up to 12 mm are also being reduced to size of 0.5 to 10 micron size. So, such high is the attrition in this kind of fluid energy because of the high speed jet that is circulating within the grinding chamber. The medium that is in general used for this fluidizing these solid particles which are to be crushed are in general 1 to 4 kg of steam or 6 to 9 kg of air per kg of the product. This is about the fluid energy mill. So, now we go to the agitated mills. Agitated mills are a kind of small batch non-rotating mills containing solid grinding medium. Grinding medium in general consists of balls, solid elements such as balls, pellets or sand grains. These mills are in general vertical vessels having capacity 4 to 1200 liters, filled with a liquid in which the grinding medium is suspended. The liquid has to be non-reactive and non-corrosive. The charge is agitated with multi-armed impellers. Whatever the feed along with the grinding medium that along with a liquid that is agitated with multi-armed impellers, so that enough agitation takes place. There is also reciprocating central column which vibrates the vessel contents at about 20 Hz. Concentrated feed slurry is admitted at the top and product along with some liquid is withdrawn through a screen at the bottom. And these agitated mills are in general found to be useful in producing particles less than 1 micron size. Next, colloidal mills. Colloid mills are in general a kind of homogenizers rather than size reduction equipment. They will be doing a kind of homogenization. What happens in general, particles are agglomerated or clustered loosely in general. Lightly clustered particles or agglomerated particles are there, they may be forming a kind of bigger lumps. So, those kind of particles may be disintegrated and a kind of homogenization may take place. In this colloidal mill, what we have in a kind of a stationary casing would be there, and then there will be a kind of a rotating disc would be there. So, this the gap between this casing and then disc is in general very small, like it is in between 1 to 25 microns, right. So, the feed comes in between, trapped between these thing, that will be homogenized into a kind of individual particles. Whatever the clusters are there, they will be disintegrated and then a kind of homogenization takes place. That is the basic principle of this colloid mills. Intense fluid shear in a high velocity stream is used to disperse particles or liquid droplets to form a stable suspension or emulsions. In general, these kind of mills are used for pharmaceuticals like preparing the suspensions, etc. Final size of particles or droplets is usually less than 5 microns. Often there is a little actual size reduction in the mills, as I mentioned. There is kind of almost negligible kind of reduction there in the particle size, but there is a kind of disintegration of the clusters or the agglomerates. Principal action in the disruption of lightly bounded clusters or agglomerates, that is the principal action that is taking place in colloid mills, that is they will be disrupting the lightly bounded clusters or agglomerators so that by disintegration a kind of homogenization of the suspension takes place. In general, syrups, milk, purees, ointments, paints and greases are typical products using colloidal mills. The chemical additives are often useful for stabilizing suspensions as well. So, typical schematic, if you see, we have a kind of casing like this, casing that is for a colloid mill like this, and there is a rotor with a kind of disc kind of shape. Some different types of discs are possible. These discs are in general connected to a kind of a rotor which rotates. It rotates in this direction whichever we are we need to rotate. It can be rotated in either of the direction, but in general they are rotated in one single direction. So, this is the one that this kind of thing that is connected to the rotor is rotating. Whatever the feed that is there, that comes in here from here like this, and then trapped between the narrow space between these two casing and rotor. So, whatever the feed that is coming here, that will be disrupted and formed a kind of individual particles having kind of homogenization or individual droplets. If not individual, a kind of smaller droplets will form. Smaller particles will without any kind of agglomeration or clustering kind of thing. So, whatever the cluster or agglomerated kind of particles are there, they will be broken down when they come between this casing and rotor, because when it rotates those particles will be disrupted and then product is collected as a kind of homogenizer products. This is a kind of very much useful mill in general for a kind of given suspensions, purees, ointments, greases, etc. So, the feed liquid is pumped between closely spaced surfaces, one of which is moving relative to the other one at speeds as much as high 50 meter per second or more. So, the speed is very much high in general, because that is required, because these particles, though they are clustered or agglomerated, the size is not very high, maybe 20 to 30 microns or something like that, and then you need to do the disruption of those clusters so that you can have a kind of particles or droplet less than 5 microns or something like that. So, you need to have a kind of very high speed in this case, and then because these surfaces are almost touching to each other, the gap is very much narrow. So, what happens, a kind of heat generation will also take place because of the viscous dissipation, and then that heat has to be transferred, or by applying the coolant that heat has to be removed. Otherwise, the product properties may be affected, because these products in general, these purees, syrups, etc., ointments, etc., are heat sensitive products. In some design, liquid passes through the narrow spaces between a disc shaped rotor and its casing. The clearance is adjustable down to 25 microns. The gap between this casing and then rotor can be reduced to as smaller as 25 microns, that is, they are almost touching to each other. Often cooling is required to remove the heat generated in this kind of colloid mills. The capacity is in general very low, and there are two types of mills are there based on the capacity. Small mills are having 2 to 3 liters per minute capacity, whereas larger mills may have a 440 liters per minute capacity. So, depending on the capacity of these mills, they can be small mills, they can be larger mills. Okay, larger mills can handle as much as 440 liters per minute. That is a very big capacity, especially considering the type of products we are handling in these colloid mills. So, that is about the ultrafine grinders. having for dry and then wet products. For dry products, we have to use the hammer mills with internal classification or external classification, or the fluid energy medium. For the wet grinding under the ultrafine grinding conditions, you have to use the agitated mills, something like colloidal mills, etc. Okay. Now, we see some details about the cutting machines. Cutting machines in general, in some size reduction problems, what happens, the feed stocks are too resilient to be broken by compression, impact or attrition. That is quite possible depending on the nature of the feed, but often we have such kind of feed stocks while undergoing size reduction operation. So, they are very resilient to be size reduced by the compression, impact or attrition. Sometimes feed must be reduced to particles of fixed dimensions, that is also required depending on the situation. In some problems you need to have the feed of definite fixed dimensions. These requirements can be met by machines known as the granulators, which yield more or less irregular pieces, but the same requirement can be met using the machines called as the cutters, which produce regular shape of particles such as cubes, thin squares or diamonds. Whereas the granulator, they yield product of more or less kind of irregular shapes. If you use the cutters for the same operations, you can get a kind of a regular shape of products like cubes, thin squares or diamonds. These cutting machines can find applications in many manufacturing processes, but are especially well adapted to size reduction problems in making rubber and plastics. They are also finding applications in recycling paper and plastic materials as well. So, now we see equipment available for cutting machines. So, let us take an example of rotary knife cutters. So, here what we have a horizontal rotor here as shown here. There is a horizontal rotor here like this, which may be carrying several flying knives like this. These knives are in general flying kind of thing. So, whatever the feed that is coming in from here, that will be undergoing a kind of size reduction by this flying machine. So, this size reduction, this cutting is taking place until and to a kind of desired size. So, they will be continuously undergoing a kind of a size reduction, because there is a screen at the bottom at the discharge. So, whatever this size, specified size is met by the size reduction, those particles are undersized particles are taken to the discharge, whereas the oversized particles they will be inside the machine only, and then they will be further undergoing size reduction by these flying knives. So, that is the basic principle in this rotary knives. So, here what we have seen, it contain a horizontal rotor turning at 200 to 900 rpm in a cylindrical chamber. On this rotor there are 2 to 12 flying knives with edges tampered steel passing with close clearance over 1 to 7 stationary bed knives. Feed particles entering from above may be cut several times before they are small enough to pass through a bottom screen with 5 to 8 openings. So, these particles whatever are coming from the top, they will be undergoing cutting several times until the size becomes 5 to 8 size, and then the particles smaller than 5 to 8 size, they will be collected through the discharge at the bottom, whereas the particles larger than the 5 to 8 they will be retained inside the machine, and then they will be further undergoing a kind of a cutting action by these flying knives. So, that is about the rotary knife cutter. So, there are different types of cutters, cutting machines are also available industrially, right. So, those details can be found in a kind of book by the Colson and Richardson, chemical engineering series, second volume. There are several types of equipment are available under each category of crushers, grinders, ultrafine grinders and cutters. They have also discussed different types of industrial equipment as well. So, we have seen some of them. If the readers are interested, may go through that book for more and more details about different types of industrial size reduction machines. Readers may also go through another book by Brown et al., that is Unit Operations by Brown et al. They have also discussed several types of industrial size reduction machines available. So, having seen some basic details about the size reduction equipment under the category of crushers, under the category of grinders, under the category of ultrafine grinders, and under the category of cutting bench, it is important to find out what is the criteria for the size reduction, or the selection of what is the criteria for selection of size reduction equipment, which equipment should you use for a given application, that is again kind of important. So, we see those details now. Criteria for size reduction process: one must know that the crusher, grinder or cutter cannot be expected to perform satisfactorily unless the feed is of suitable size and enters at a uniform rate. As we have seen just now, if fluid energy mill can handle particle as larger as 12 mm, but if the particles are smaller, it will be more effective. But if you have particles like 20 mm or 50 mm, that cannot handle. So, the feed should also be suitable size for a given operation, right. So, that is very much essential for a given applications, right. Okay. So, similarly, if you have a jaw crushers etc., that handles big lumps directly coming from the mines, but the same equipment if you use for the fine particles or having size 1 mm or less than 1 mm, something like that, they will be not effectively doing the size reduction operation. So, one must be very specific about the feed size, and then accordingly one has to choose a kind of equipment required for the size reduction. Sometimes the product size also matters, depending on the what type of product, what size of the product that you need, then you may choose a kind of equipment, right. So, there may be equipment which may be handling a given feed. Let us say if feed it is having 30 mm size, you may find there are 2-3 types of equipment that can handle, but if you see the product, some of that equipment may be producing 1 mm or 2 mm particles, whereas some of that same equipment which can handle 30 or 40 mm particle feed, they may produce the particles of 0.001 mm, something like that, or some micron size particles they can produce. So, sometimes it also becomes that the not only feed size, the required product size also makes a kind of essential criteria for selection of the size reduction equipment. Also, feed must be entering at uniform rate, that is another important thing if you wanted to have a kind of satisfactory crushing. Product should be removed as soon as possible after particles are of desired size are achieved. So, you cannot retain particles, let us say you need to have a particles of average size 1 mm from the feed size of average 100 mm. So, once the particle size you realize that they are almost like 1 mm particle size, they have been reduced to 1 mm particle size, it is better to remove the product as soon as possible. Otherwise, those particles may further undergo kind of size reduction, and then the size of the particles may be become much smaller than required 1 mm. Or in other cases, it may be like it may not be doing the further size reduction beyond that certain product size of 1 mm or 0.5 mm, something like that. Under such condition, if you are not removing the product, you may be wasting the energy further. So, as we have already discussed, the energy is a kind of important factor here. So, that way also in terms of energy saving also, it is better to remove the product as soon as the desired size is achieved. Then it is always advisable to keep the machine out of unbreakable material. There are some types of attrition mills we have seen where one of the discs may be mounted spring mounted, so that to avoid breakage because of the unbreakable material being trapped between the disc. But such provision may not be available for all types of size reduction equipment. So, it is always advisable to have a feed which can be broken. So, any unbreakable or unbreakable material is there, that must be kept out of the machine. So, the feed has to be carefully checked, so that to avoid any kind of unbreakable material should not be present in the feed. In the reduction of low melting or heat sensitive products, the heat generated in the mill must be removed, otherwise the product properties may be changing, right, like in a kind of colloid mills etc. Okay. So, when you maintain these kind of conditions, then only you can expect a kind of size reduction equipment is performing satisfactorily. Otherwise, you may not be satisfied with the performance of the equipment, as well the power consumption may also be higher, and then capacity may also be not significantly high as you expected. So, it is necessary to keep this point in mind before selection of the size reduction equipment, and then the saving of the energy as well. Therefore, what we understand from these points, the heaters and coolers, metal separators, pumps and blowers and constant rate feeders are important adjuncts to a given size reduction unit. So, wherever the heaters and coolers, like if any heat removal or heat addition is required, so then we may need heaters or coolers. If you wanted to maintain the feed free from unbreakable materials such as metals, etc. So, metal separators are also found to be kind of a good adjunct for these size reduction equipments. And then definitely pumps and blowers, we have seen already the several types of pumps and blowers are involved in kind of size reduction equipment. Also constant rate feeders are also kind of very much essential in order to have these machines performing satisfactorily. Then the mode of operation, open and closed circuit operation. If the material, if you feed material you have taken in a mill and then you have done a kind of size reduction, and then whatever the material that is coming as a kind of product, you directly take out without being separating them as a oversize, undersize, then you can say that a kind of a open circuit operation. That is, you do not product whatever is there, you are not classifying into the different sizes, and then you are not sending back the oversized material to the mill for further reduction, then you can say that is a kind of open circuit operations, right. But in general, it is most of the mills run in a closed circuit mills, where the power savings is also kind of important factor. So, what you do, you do a kind of size reduction equipment, then you classify the product into the oversize and undersize. Undersize you may be taking as a product, oversize may be sending back to the mill for further reduction. So, the circuit is closing by the feedback kind of thing, or returning the oversized material to the crushers. So, that way those kind of mills we call as a kind of closed circuit operations. That is the only basic difference between the open and closed circuit operation. In the open circuit operation, there is no returning of some of the product to the crushers for the further reduction, whereas in closed circuit operations, there is a certain amount of material from the product which is oversized is sent back to the crushers or mills for further size reduction. So, that is happens in the closed circuit operations. So, a kind of recycling is there in the closed circuit operation, whereas in the open circuit operation there is no recycle kind of operation. Now, we see some of these details about them. The mill is said to be operating in open circuit if no attempt is made to return oversized particles to machines for further reduction. So, if you are not making any attempt to return oversized particles to machine for further reduction, then you can say such kind of mills are operating under open circuit conditions. This may require excess amounts of power in general. Why? Because sometimes because of much of energy is wasted in grinding particles that are already fine enough. Because what happens when you do a size reduction operation in a given mill or crushing equipment, or in a size reduction equipment, after a certain time of operation, the satisfactorily the product is more or less of satisfactory size as per the equipment restrictions, feed and product requirements. So, but then in such case, if you are not separating the undersize, you are unnecessarily wasting the energy for the material which is already sufficiently fine enough. So, that way it is not going to be helpful anyway. So, it is often economical to remove partially ground materials from the mill and pass it through a size separation device. Undersize may be taken as product, oversize may be taken as a kind of return to the recycle to the size reduction chamber for the further size reduction. This way what we can have, one can save the energy as well as the specific size product size requirements can be maintained. If not exactly uniform, the product size distribution may be very narrower in the case of a closed circuit operation, but in the case of open circuit operations the product size may be broader, the distribution of the product may be broader, whereas in the closed circuit operation, since the undersize are separated, oversize are sent back for the further reduction. So, the further reduction will take place, and then more or less final product after the end of the operation, we may have a kind of narrow product size distribution in closed circuit operations. Separation device is sometimes inside the mill, but in general it is outside the mill. If you have a kind of, we have ultra fine grinders like something like hammer mills with the internal classifications. So, like in such kind of arrangements, we have the classifiers or the separation devices there. So, similarly the separation device may be inside the mill, but that is not possible for all type of machines. Commonly these separation devices are outside the mill. Now, schematically we see how a kind of a closed circuit operation taking place in size reduction mills. So, let us say we have a very big size of particles, directly the material run away from the mines whatever are there in big lumps like 1500 mm, 2000 mm size particles. Those can be taken into a gyratory crushers for example. Okay. So, there the size separation is taking place. Okay. Whatever the product that is coming from these gyratory crushers, that you can pass through screens, right. So, here obviously you have three types of products: coarse, intermediate and then fines. Usually many coarse will be there, right. That coarse may be taken back and then recycled to the gyratory crushers again, whereas the intermediate products may be taken to the next level in the rod mill, right. So, this in here in the rod mills the further reduction may be taking place. So, the rod mill, whatever the products are there, they can be separated as a kind of oversize and then undersize kind of material, right. So, whatever the material that is coming from the ball mill, if you are separating, that is fine, you can separate, and then if you want oversized material you can send back here, but let us say you do not have such kind of oversize or undersize separation here. So, whatever the product that you are getting from here from the rod mill along with the fines that you obtain by the gyratory crushers, all of them you can take to the ball mill. It is optional, it is just a kind of example we are seeing. So, you can also have a kind of a screen or separation section after the rod mill also. So, here what we are taking, the entire product from the rod mill as well as the fines from the gyratory crushers are taken to a ball mill here in the ball mill, right. From the ball mills, what you can do, you can do a kind of separation where oversized undersized particles may be separated, right. Oversized particles may be sent back to the ball mill again for the further reduction. Undersized material can be taken as a kind of product, as a kind of slurry. Okay. So, this is how a kind of a general closed circuit operation takes place. It is just a kind of typical arrangement to show a kind of crusher category equipment and then a kind of grinder category equipment, along with in addition to that one there is a kind of a separation by the centrifugal forces. Is a kind of general representation, but it is how it looks as per the requirement of your product, depending on the feed and then depending on the equipment that you have, depending on their capacity, etc. One can arrange kind of this equipment size reduction in such a way that you can operate in a kind of closed circuit mode and then save as much of energy as possible and then get a product as much narrow particle size distribution as possible. That is the advantage for this particular closed circuit operations. So, closed circuit operation is applied to action of a mill and separator connected to that. Oversized particles are returned to mill. Energy must be supplied to drive the conveyors and separators in a closed circuit operations or closed circuit systems. In general, what happens in open circuit system, there is no requirement of energy supplying to the conveyors or separators, etc. But here in the case of closed circuit operations, we may need to provide additional energy for this operating of for these conveyors and separators. However, despite providing the energy, sufficient energy for operating these additional things like conveyors and separators, still you can make a kind of a energy saving compared to the open circuit operation, and that energy saving is as much as high as 25%. So, despite of this additional energy supplied to conveyors and separators, reduction in total energy requirement over open circuit grinding is often reaches up to 25%. So, despite having this additional energy requirements in the closed circuit operation, still there is a kind of energy saving compared to open circuit operations, and that energy saving can be as much as 25%. Now, we see preliminary guide for selecting size reduction equipment. So, we have seen different types of crushers, different types of grinders, different types of ultra fine grinders, and then a few types of cutting machines as well we have seen, and then we have also seen the mode of operation which is going to be feasible, and then criteria for selection of the equipment, etc., or criteria for a proper satisfactory operation of this size reduction equipment. But you need to have a kind of preliminary guide in selecting this equipment as well. Which equipment should you use? So, first is the material, what type of material that are you choosing, that makes a difference, and then what is the feed size, what is the average size of the feed, that also makes a difference in selection of this equipment. So, that guide we see especially for those equipment we have studied in these last 3 lectures. So, here what we have a table which gives details about the name of the equipment, what is the maximum feed size this equipment can handle, and then what is the minimum product size that you can expect from this kind of equipment, and then what is the capacity in tons per day, and then where are the applications that you find for this kind of equipment. So, first equipment that we have studied is jaw crushers. The maximum feed size it can handle up to 1500 mm, and then minimum product size it can produce up to 150 mm. It can have the capacity, wide range of capacity, less than 1 ton per day to almost 1000 tons per day. It can handle wide range of capacity, and then applications in general we can find in any metallic and non-metallic minerals industry. Next one we have gyratory crushers. It can handle maximum feed size as much as 2000 mm, and then it can produce minimum product size as much as 300 mm. The capacity is in general very high, more than 1000 tons per day. These are also find applications in metallic and non-metallic minerals. Then roller mills, smooth and tooth roller mills we have seen. We have seen 2 types of roller mills, smooth and tooth roller mills. So, they can handle maximum feed size up to 30 mm, and then they can produce products of minimum product size of 1 mm. Their capacity is also very wide, 1 to 1000 tons per day. Applications are in cereals, vegetables, calcite, kaolin, etc. Then we have hammer mill. They can handle particle size up to 40 mm, whereas the minimum product size can be 0.01 mm. Now, you can see the roller mill and then hammer mill, the maximum feed size they can handle is almost close to each other, 30 to 40 mm, but you can see the product size, minimum product size is very much different. Roller mill can produce product up to 1 mm only, whereas the hammer mill can produce the product up to 0.01, because of the, in addition to impact, there is a kind of attrition also taking place in hammer mill. So, you need to have a product less than 1 mm or less than or close to the 0.1 or 0.01 mm. So, though the feed is of suitable range for the roller mill, you have to go for a hammer mill, because your product size is finer than 1 mm, or your product size requirement is finer than 1 mm or smaller than 1 mm. The capacity here again, the capacity for hammer mill is very wide range, less than 1 ton per day to 1000 tons per day it can handle. The applications you find in general in phosphates, pigments, dried fruits, etc. Then we had a disc attrition mill which can handle the feed size, maximum feed size of 12 mm, and then it can produce particle size of 0.07 mm. The capacity is again less than 1 to 1000 tons per day. The material applications in general where we use this disc attrition mills are cellulose, asbestos, rubbers, etc. Then we have a ball mill where the different types of balls have been taken as a kind of grinding medium. So, it can handle the feed size, maximum feed size 4 mm, but it can produce the product size up to 0.3 mm only. The capacity varies in between 10 to 1000 tons per day. The material it handles in general calcite, kaolin, ceramics, etc. Then fluid energy mill, it can handle up to 30 mm, and then it can produce product up to 0.001 size, okay, that is almost 1 micron size it can produce. But however, just now we have seen if the feed size is less than 12 mm something like that, then it performs very much better. The capacity is in general less than 1 ton per day to almost 100 tons per day. These fluid energy mills finding several applications in ceramics, pesticides and pigments industries. Then agitation mill just now we have seen, which handles maximum feed size is 0.075 mm and then minimum product size in general 0.005 mm. The capacity varies in between less than 1 ton per day and 100 tons per day. Applications it finds in silicon, titanium oxide and ceramics kind of material. So, this is about the size reduction equipment. The different types of equipment we categorize like crushers, grinders, ultra fine grinders and cutters or cutting machines we have seen. Under each category specific type of applications we have seen. So, the material that has been discussed in these 3 different lectures covering variety of size reduction equipments have been collected from these reference books McCabe, Smith and Harriet, that is Unit Operations of Chemical Engineering. Then another book Unit Operations of Particulate Solids Theory and Practice by Ortega Rivas. Then Colson and Richardson's Chemical Engineering Series, 2nd volume by Richardson and Harker. Then Transport Processes and Unit Operations by C.J. Giancopoulos. Then Unit Operations by Brown et al. And Introduction to Chemical Engineering by Badger and Banchero. Primarily the details that have been discussed under the size reduction equipment have been taken from these 3 books. Majority of the information is taken from the McCabe and Smith and then Richardson and Harker. Some details, some figures are also been taken from this Ortega and Rivas. But however, for additional information about different types of industrial size reduction equipment, one can go through Richardson and Harker, that is Colson and Richardson's Chemical Engineering 2nd volume. Also one can go through the Handbook of Chemical Engineering, that is Perry's Handbook of Chemical Engineering. If you go through this book, chapter number 21, you can have a wide variety of size reduction equipment especially used for industrial applications. Thank you.